This is a fairly simple test here. We'll talk a little bit about that. Like fundamentals test 9 is what this is. Like charges do what? Like charges. Huh? No, actually what you're going to do is you're, when you say, think about two magnets. If I've got two north poles, yeah, they repel from each other. They push away. So this is like I say, since we're in the fundamentals thing, we're hitting basic electricity stuff here, but that's not really, it doesn't hurt to burn that in and talk about it a little more. Which unit of electricity measures the amount of current flow, which is very easy to do. As temperature increases, what usually happens?
Resistance increases.
Yeah, but that's positive temperature coefficient. The sensors that we have are negative temperature coefficient. They're engineered to work the opposite of that, which is very strange. In other words, but that's just the way it is. You know, whenever you see what does your sensor voltage do whenever you increase the temperature? What does the sensor, like an engine coolant temperature, what does the voltage do if you're looking at it? Let's say you're measuring it, you got two wires going to that sensor and you're back probing one of them, let's say, you don't want to pierce the wire, you just want to back probe it in the sensor, and you're going to measure it. As the engine coolant temperature increases, what does the voltage do at that sensor? You remember? What does it do? What's fed to it? If I unplug that sensor here, and I've got that sensor here, and it's disconnected, you know, there's this little connector here, and it's got the two wires going to it, like that right there, and I got two terminals right here. And if I took my meter and I measured from one terminal to the other with my meter, all right, what's my meter going to read? Usually about 4.6, roughly. If it's a two-wire sensor, you're going to see 4.6 on those two wires. Now, with it disconnected, what's my scan tool going to read? It's going to read minus 40 if it's a temperature sensor. Because that voltage, whenever it's at maxed out, it's going to read 40 degrees below. 40 below, which is basically where that scale stops on, you know, if it's any colder than that, it's, you know, it's going to be stupid anyway. All right, so if I short this out, it goes really, really, really hot, you know, super hot. And usually, though, if it's totally shorted out, the computer knows there's something wrong. If it's disconnected, if it's not. Now, here's the other thing, and I'm kind of getting into some OBD2 stuff here at OBD, but, and this is something I'm going to tell you eventually, and I'm kind of forging out of here. Every engine controller has got two rooms in it. And whenever you go into your, you know how whenever we go into our scan tools, and you guys have fooled with scan tools enough to where you're typically going to go into your scan tool and pick the vehicle, right? When you go in there and you pick the vehicle and you say this is a, you know, a 99 GMC Sierra 5.3 under 8500 GVW, no air pump and all that hogwash, you're going right into the enhanced. Well, that's the enhanced room. We're going to call that the E room. I don't know what everybody else might call it. That's what I call it. And this right here is the OBD2 room. All right, the OBD2 room will sometimes, and I've seen this, and this is weird. Like I say, we're in fundamentals electrical, but I'm hitting you with this anyway. OBD2 can actually have a code stored that has been erased from here. That doesn't happen very much. But one time on an Escort, just like the one Derek's driving right now, I saw a cylinder 4 misfire, PO304 code, and I cleared it on the OBD2 side, or I'm sorry, on the enhanced side, but the check engine light stayed on even though I had fixed the problem until I went in the OBD2 room and cleared it out of there too. There's a lot of guys out there that don't even know these codes are stored in two different rooms. You understand what I'm saying? So just remember that. Anyway, I'll tell you where else I was going with that. If I disconnect a sensor, a lot of the times the enhanced room is going to substitute a value like 101 degrees, just because it feels like that's a sort of a middle figure that may work, right? This OBD2 room is going to show minus 40. Now, this is a lie, isn't it? This is not the truth. But minus 40 is telling you there is something rotten in Denmark. if it's close to 101, you may think that that's an accurate reading, you see. But of course, it typically usually will throw you a code too. But make sure you understand there's 2 rooms in those engine controllers. So it's a good idea to dive into that OBD2 room, see what's in there before you go to the advanced room. Make sense? Got me? Okay. Now that's where I was going with that. I sort of got sidetracked here. Outer electron shell is known as what?
Valence ring.
Valence ring. Will you see how you're burning that in? Semiconductors have how many electrons in their outer orbit?
4.
4. What type of material is indicated by this atomic structure that has 6 electrons in its outer valence ring? You know, it can have as many as 8, but if it's got more than 4, it's going to be an insulator, right? If it's got less than 4, it's going to be a conductor. If it's only got 1, it's a really good conductor. If it's got 8, it's a really good insulator.
I have a question about number 6.
Okay.
Wouldn't semiconductors actually vary, because as you go down the periodic table of elements, the number of valence electrons increases?
Well, yeah, well, actually,
But the rings can only hold 8 apiece.
yeah, there's only 8 that's available
So
there. As
you
far as
can have
valence
more
rings,
but
yeah, there's an outer, that's the outer shell. That's the part that decides whether it conducts electricity or not. But basically, you're making a good point there and asking an intelligent question. And that's what we're basically looking at there is what he was talking about. The valence ring is the one we're concerned with when we're talking about conducting electricity. And if it's got 4, you're always going to have, I mean, that's going to be one that only conducts electricity under certain circumstances, you know, for the most part. Now, how they counted those electrons, I don't know, because I know they didn't say 1, 2, 3, 4, you know what I'm saying? I mean, don't ask me how they came up with that.
They call them behaving differently.
If an insulated wire rubbed through a part of the insulation and the wire conductor touched the steel body of a vehicle, that's called a what?
short to ground.
Short to ground. Yeah, how many times you hear people when something doesn't work right say it's got a short in it? They always say it's got a short. Well, sometimes it's an open. A short and an open's the opposite. If somebody's cut a wire, it's not a short. You know, if they've cut it in 2 and it's just dangling on both ends, that's an open circuit. Okay, if 12 volts are being applied to a resistance of 3 ohms, how many amps will flow?
4.
4. Got that? You got that right. And that's your E-hour thing. High resistance in an electrical circuit can cause what? A, dim lights. B, clicking of relays or solenoids. C, any of the above. D, slow motor operation. Isn't that something? That's a scrambled up bunch of questions. Any of the above. Slow motor operation can be caused by that too. So.
No, you skipped number 4 and 9 before we go to.
Did I have a good time with those? Back up. Number 4. What's the unit of electrical pressure?
I'm assuming C.
Huh?
I'm going to assume C.
D is actually volts electrical pressure. You know what a coulomb is?
That's
A billion electrons. That's what that is. Isn't that weird? How many? I mean, how you gonna count those? All right. Okay, so if 2 insulated wires are melted together where the copper conductors touch each other, that's called a short voltage. But only if one of them has got voltage. See, they asked this question the right way. If 2 insulated wires were melted together where the copper conductors touched each other, you know, what if they're both grounds? You know, they didn't say what was flowing through either one of those wires right there. Okay, if 200 amps flow from the positive terminal of a battery and operate the starter motor, how many amps will flow back to the negative terminal of the battery? Huh? Well, actually, the amperage is the same in all of the whole circuit. This is a starter. It's just real simple drawing. You're going, no matter where you measure that amperage in that circuit, it's going to be the same. Yeah, that's a return. Now, remember what I told you about this? Whenever the electrons are all on one side of those plates, they're looking for a path to get to the other side. So as they start flowing, they're going to be flowing the same, you know, at the same volume, no matter where you are in the circuit. The only thing that, you know, even if you've got loads in series, that is, and this whole series is collectively pulling 200 amps, you're still going to be measuring 200 amps anywhere you go. Voltage will be different, but the amps won't. You get what I'm saying? The amps are always going to be the same. Because that's basically, it's just a big loop. And so always remember that wherever you measure the amps in a circuit, it's going to be the same. All right, now then, inductive amp meters work because of what principle?
Magic.
Which one?
Magic.
Ah, magic. Oh, cool. A magnetic field surrounds any wire carrying a current. All right, number 14, a meter used to measure amps is called what? Which one? That's actually going to be C, ammeter. It's not an amp meter, it's ammeter. Ammeter. Okay, so an ohm meter should be connected to the component or circuit being tested when? Only when no power is flowing, which would be an electrical open circuit. Let me tell you this. Watch this. This is weird. Okay, I've got an engine block right here, and you might notice, you know, let's just say this is the engine block, and it's going to be a real simple drawing. And I've got the windshield, body of the car. All right, I got a battery right here. You got that? All right, that battery has got hookups to, all right, the body of the car is here. The battery is going to be hooked up to the body of the car, and it's also going to be hooked to the engine block. Sometimes they have a separate little pigtail coming over. They always want the body and the engine to be grounded together. Is that right, Sean? All right, now watch this. Sometimes you will see a little ground wire going, a smaller ground wire, going from here to a little stud on the body of the car. You ever seen that before? Coming from the back of the motor back there?
I've seen them on the bell housing too.
Yeah, they're just all over the place. They ground every darn thing, you know. They got all these different grounds. All right, if I take my ohm meter, and let's say that everything is normal, and I've decided that I want to check and make sure that's a good ground. Let's say my gauges aren't working right or something, and I'm thinking that maybe have something to do with this particular little body ground up here. And I'm going to take my meter, and I'm going to hook it up to, and turn it to ohms, 200 ohm scale, and I hook it from here to there. Am I okay doing that? It confuses people. I mean, I've seen regular, you know, real full-blown mechanics that work on cars every day get confused by this. If that battery is still connected, you know, of course you got your other side of your battery hooked to your starter and it's feeding the electrical system, all that. If you try to connect, I mean, measure amperage flowing through that wire with all of this crap hooked up, you're going to get crazy readings all over the place. Because what is it? How does that ohm meter check to see if it's got continuity?
Puts its own juice through it.
A little bit of juice, just a tiny little bit of juice through it, and it's measuring how it comes out the other side. Well, if there's already juice flowing through it because of your dash lights or whatever that may be working, then this ain't gonna know what to do with its numbers that it's getting out there. So, what am I telling you? If you're gonna measure the continuity of a harness, you know, component or whatever with an ohm meter, always disconnect the battery. Now, it's not that it's dangerous so much as that you're not going to get a good reading. If you can't trust your reading, then your test is meaningless, right? I mean, have you ever had a test that anybody had you to do on a component or something, and you found out that after you did it exactly the way they said, you got bad numbers, or a false positive, or a result that wasn't a good one? You know, that makes me not want to trust that test anymore, or find out why I got bad numbers. You understand what I'm saying? That can work no matter what you're doing. All right. So basically what we're wanting to do is we want to take as few steps as possible to get as accurate reading as we possibly can. That's what we're basically all about doing. We're gathering data and we're sorting out that data so we can say, I know this and I know this and I know this, therefore this must be going on here. Okay, got that? All right, just remember to always disconnect your battery cable if you're going to be measuring wires, you know, especially can't measure wires with current flowing through them, which is all there is to it. Even if you're measuring it from one, if the wire's this long and there's any current at all flowing through that wire because the battery's hooked up, you're not going to get a good reading. That's the long and short of that. Okay, let me see. A meter is set to DC volts on the 4-volt scale. The leads are connected to a 12-volt battery. What are you gonna read?
Overload.
You're gonna read, yeah, OL, out of limits, overload, whatever that OL stands for, you know. KHZ is a unit describing what property?
Frequency.
Frequency, kilohertz. So if you got, what is 1 hertz?
That is, wavelength to wavelength,
I mean,
crest to crest,
yeah, well, kilohertz is how many hertz?
1,000.
1,000, so how many, what's 1 hertz? I mean, tell me, you know what I'm saying? Let's say I'm a really pretty girl and I'm gonna go out on a date with you, if you can explain to me what a hertz is.
I guess I'm just.
Sunk.
It's what
Okay.
makes your computer run good.
Yeah, well, that's not realistic anyway, because you're gonna have to know more than what a hertz is. But basically, the long and the short of it is, a hertz is 1 cycle per second. A kilohertz is thousands of cycles per second. Megahertz is millions. You got that? You understand that now, right? What's the difference between kilohertz and megahertz on your radio dial? Megahertz is FM, kilohertz is AM, right? I mean, it's a lower frequency, but it's also more susceptible to interference, right? Okay. Kilohertz is describing frequency. 18, to prevent blowing the meter fuse, or excuse me, blowing the meter or the fuse in a digital multimeter. A, never test the resistance of an energized circuit. B, install a fuse in line with a meter lead. Or C, both A and B. A and B is basically how you handle that. Which type of digital multimeter can measure current when clamped around a conductor? Selective, reluctive, inductive, or none of these? We talked about an inductive meter, right? The one like we got on our charge tester out here, you just clip it around the battery cable with the arrow pointing the right way. What happens if you point the arrow the wrong way on your inductive hookup? Reads negative, doesn't it? Read backwards. Finally, when measuring resistance, a reading of OL indicates it, what? More resistance than you're able to measure there. An open circuit typically, but I always start when I'm measuring resistance, I start at 200 ohms. Sometimes you might notice that when you started at 200 ohms, if you're measuring something that's 250 ohms or higher, it'll flash a reading and then it'll go away. Have you ever seen it do that? It'll flash a reading and then go away and there's nothing there. And so you click it up one range and you see if you read anything there. If it flashes and goes away, then you click it up one more range. We want to read our resistance on the lowest available scale. Can we do that? Can you remember that? And you also know that when you've got the meter set up to read amps, you don't ever hook it from the positive to the negative side of the battery. I can get a brand new one of these little cheap $10 meters I get out of the box, and I can hand it to somebody, and I've told them, don't ever measure both, and they'll plug that thing in and put it in amps and touch it to the positive and negative side of the battery right to start with, and light off the fuse in the meter. Just like that. That's one of the reasons that I don't have $300 fluke meters around here, because the fuse in a fluke meter costs from $4 to $7, depending on where you buy it. Them little silly little Radio Shack micro fuses you get that go in these meters here, they don't cost hardly anything. But I mean, I've got a meter that I use. I mean, if it was my personal meter, when I was working at a dealership, it was like a $300 meter, and the fuse in that doggone thing, you can buy lunch for what that fuse costs.
But when you're reading ohms or measuring ohms, and you're getting I've noticed I've got a lot of it'll just have the number 1 up there, and I know that's not the dang resistance.
No, it's because it's not. You need to go up a range. And we go up to 200. Go up to 2,000, 20,000, and like I say, you always. Let's say that you just start at 20,000, and you're getting a reading. You're going to go down until you don't get a reading, and then go back up until you do. You want to get it on if you want the most accurate reading, you're going to get the lowest scale that it'll read on. If it won't read on 2,000, yeah, you're going to have to measure it on 20,000. But if it'll read on 200, put it on 200. If you put it on 20,000 and it's let's say it's got 50 ohms, and you're on the 20,000 ohm scale, that's going to look like a dead short, isn't it? So you basically want to go as low as you can, especially if you're looking for something like that. Sometimes on these cars that used to have these idle speed control motors on them, it had 4 wires on it. Right here, there was 4 wires, and because they had a cord going over here to this idle air control motor. And when you put your finger on the tip of that thing, it was basically supposed to open a circuit between two of these leads. And I would get my meter, like if I had one that wasn't idling right or was cutting up or something like that, the first thing I'd do is unplug that idle speed control motor, and I'd measure it. And whenever you put your finger on the tip of that thing, it ought to be open. When you let go of it, it ought to read 0 ohms. And with it on the 20 ohm scale, I would be seeing anywhere from sometimes 15 ohms to 50 ohms or something like that, because that little switch in that motor was dirty. But listen to this, Sean, this is where I'm going. If I put it on 20,000 ohms, of course my meter was an auto ranging meter anyway, and you got to learn how to use one of them too. But because you got to watch the little words, if it says M ohms or K ohms or just ohms, that's going to determine what your reading is. But anyway, I would see crappy, 40, 50 ohms resistance there. And one day this guy came over and he says, this tempo don't run right. And it had one of those on it. And he was from an old man that had a shop over in somewhere. And so I checked that thing and I said, that idle speed control motor is going to have to be replaced. And it's about $140. He goes, gosh, that's expensive. Can't we look somewhere else for the problem? And I said, let me ask you this. If you were working on a car that had points on it, and it was cutting up and popping and snorting and not running good, what do? He said, well, I pull the distributor cap and look at the points. I said, okay, let's say the points are about to close up and burned up and all that. What are you going to do then? Well, I'm going to put points in it. Well, why didn't you put the cap back on and look somewhere else? Well, you got to find what you fix first. I said, yeah, we just found something. I mean, there's $140, but that's got to be right or this car ain't never going to run right, Now, anyway, he just really didn't like the price, because he didn't want to have to go back and tell his customer he needed a $140 part. And, he really had a heart to help his customers and all that. But sometimes, you just got to sing the blues, if they need expensive stuff, they're going to buy it. That's just all there is to it. But, I'm not going to try to sell anybody something they don't need. That's unethical. All right, everybody happy with that?
What was 20?
Number 20? What was number 20? Read the question to me.
When measuring resistance, a reading of OL on the DMM indicates.
You got to go up a range. Now, those little meters that we've got don't read OL. That's what you were saying earlier. Okay. All right.